Okay, so the quiz is going to be tomorrow. It's on sections 1.1, 1.2, 1.3, and 1.5. So looking at number 1, we need to write the equation of a line through the points -3, 2 and 3, 7. So the first thing we need to do is find out what our slope is. Our slope formula is y2 minus y1 over x2 minus x1. So we need to label our points as x1, y1, x2, y2. And then we just plug it in. So we have 7 minus 2 on top and 3 minus -3 on the bottom. 7 minus 2 is 5. 3 minus -3 is 6. So our slope is 5/6. Now we need to plug this into our equation of the line. Now we could either do slope-intercept form here or point-slope form, which on the quiz it may be specific and ask you slope-intercept form, so let's do slope-intercept form. So that's our y is equal to mx plus b, and we need to plug in y, we need to plug in m, and we need to plug in x to find b. So we could use either one of these points here. I'm going to use the first one just because I think 2 is easier to work with than 7. But again, it doesn't matter which one you work with. You can do either one. So we have 2 is equal to, our slope was 5/6. X is -3 plus b. And then we just solve this for b. So we have 2 is equal to 5/6 times -3 would be -5/2 plus b. Now we can either multiply our whole equation by 2 to get rid of that 2 on the denominator, or just add 5/2 to both sides. So we have 2 plus 5/2. We need our denominators to be the same, so we can change this to 4/2, which makes this 9/2. So b is equal to 9/2. And now that we have m and we have b, we can plug that into our y is equal to mx plus b.
Ms. Carver, is this going to be on Canvas?
That's the slope.
Right, so our point slope form would be y minus y1 is equal to m times x minus x1. So then we have y minus our y1 is 2 is equal to our slope. And then we have x minus x1, so this would be x plus 3. So this is point slope form, and this one's slope intercept. But make sure you guys know how to do slope intercept. Any other questions from number 1? All right, let's look at number 2. So are the lines parallel, perpendicular, or neither? The way we can tell if they're parallel, perpendicular, or neither is looking at their slope. So parallel has the same slope. Perpendicular is the opposite reciprocal slope. And then neither is just 2 totally different slopes. So we need to get our equation to be in slope-intercept form so we can clearly see what our slope is. So for our first equation, 3x minus 2y is equal to -9. We need it to be y equals, so we just have to rearrange this equation. So I'm going to move 3x on both sides. So I have -2y is equal to -3x minus 9. And then just divide everything by -2. So y is equal to 3 over 2x plus 9 over 2. So our slope here is 3/2. Now we need to do the same thing for our second equation. So we're going to subtract 6x on both sides. So we have negative 4y is equal to negative 6x plus 5. And then divide everything by negative 4. So y is equal to negative 6 divided by negative 4 simplifies to 3/2. So 3/2 x minus 5 over 4. So our slope here is 3/2. Since our slopes are the same, are these lines parallel, perpendicular, or neither?
Parallel.
Parallel. For number 3, we're going to do the same thing, but here it gives us points, and we have to find the slope using those points. So again, if it's parallel, we have the same slope. Perpendicular would be opposite reciprocal slopes, and then neither is just two totally different slopes. So our slope formula is the change in y, so y2 minus y1 over x2 minus x1. I always like to label the points before I start, so I have x1, y1, x2, y2. And then I just plug them in. So we have 5 minus 2 on top, and 3 minus negative 1 on the bottom. So we end up with 3 over 4 for our slope. And we do the same thing for our second set of points. So we have x1, y1, and x2, y2. And we plug them in. So we have 10 minus 7 over 8 minus 4. And we get 3 over 4. Our slopes are the same. So are these lines parallel, perpendicular, or neither?
Parallel.
Parallel. Any questions here? Okay, number 4. We need to find the domain, range, and interval of increasing and decreasing for each graph. So let's start with our domain. So remember, our domain goes from left to right. So we start at our furthest left point. We see that we have an open circle here. An open circle means that we're going to use parentheses. So we have parentheses, -3, and then our furthest right point of this graph is 1. And then that's a closed circle, so we use our bracket. Our range, we start at the bottom and go to the top. So the first point that our graph reaches on the bottom is -4. And then our highest point is 0. Even though this is a closed circle, we include 0 because our graph is continuous through 0, so we would put a bracket there. So this relative max here is why we would put a bracket. So remember, domain, you're always looking at the x values. Range, you're always looking at the y values.
So if that point at 0 was at 1, we wouldn't put the brackets.
if it was, let's say that our graph went like this, our highest point then would be this open circle, and then we would put a parentheses.
And if that line was higher, then it would be that number, obviously, for the...
Yeah, so then if it was higher, we would still put a bracket. We only put a parentheses if it's an open circle or if it is infinity.
Okay.
And that's for domain and range, but for increasing and decreasing, we always use parentheses. So let's look at increasing and decreasing now. So just starting from left to right, our graph starts off decreasing until we get to when x is -2. So our first interval of decreasing is going to be -3 to -2. Then from -2 to when x is 0, we're increasing. So our first interval of increasing is -2 to 0. And then our graph ends decreasing from when x is 0 to when x is 1. So here we wouldn't be using infinity for anything because our graph stops. We see that we have those dots there, so our graph is not continuing forever, it stops. So our domain or intervals of increasing wouldn't be going to infinity because our graph stops. Any questions here? Matthew, you're muted if you're asking a question.
Oh, so increasing and decreasing is only x values, right?
Right. So
Okay.
these both are always x values.
Yeah, all right. Thank you.
All right, let's take a look at B. So first thing, our domain. We start at our furthest left point and go to our furthest right point. Here we have arrows, so our graph is continuing forever in this direction. So what do you think our interval for our domain is going to be?
All real numbers.
All real numbers. I don't know how it's going to look on the quiz. It could be -infinity to infinity. It could say all real numbers. So just know that those two are the same thing. Next, we have our range. So remember, our range starts at the bottom, so our smallest y value, and then goes to our largest y value. So what would our range be?
-2 to infinity.
Perfect. So our graph starts at -2 and goes to infinity. Awesome. So remember that -2 just has to have a bracket.
It wouldn't be 4.
No, because we're looking at the highest values of our graph, and we see that our graph keeps going forever up.
Oh, okay.
Okay, now looking at increasing and decreasing, we see that our graph starts off decreasing until we can just say that that is when x is, I guess, -1.9-ish. So it starts decreasing, and we have arrows, and our arrows are pointing left. So we start with our interval at -infinity, and then it stops decreasing at -1.9. Then we start increasing from negative 1.9 till we hit x is equal to 0. So our first interval for increasing is going to be negative 1.9 to 0. Then we go back to decreasing from 0 to positive 1.9. And then we go from positive 1.9 to infinity.
Do we have to put those in order?
No.
Or can we just list them?
You just list them. So I always just like to start from left to right for our graph. That way I just make sure I get like all of the intervals, but you just have to list them. It doesn't matter what order.
Ms. Carver,
Yes.
why is it 0 for when you increase? Wouldn't it be like 4 since it's on 4?
Because remember when you're looking at the intervals of increasing and decreasing, you always look at the x values. So here we increase from this point to this point. So when x is negative 1.9 to when x is 0.
Oh, got it.
So increasing and decreasing intervals, we always look at the x values. When you're doing increasing and decreasing, it's always going to be brackets. When you're doing domain and range.
You mean parentheses?
Yeah,
right?
parentheses. I'm sorry, parentheses. When you're doing domain and range, it's only parentheses when you have negative infinity, or if you have a hole in your graph. So an open circle. You're welcome. All right, so going back to the two that I skipped, so C and D down at the bottom. First we need our domain. We start all the way on the left side of the graph. This is a closed circle, so we have a bracket, -4. Then we look at our highest x value here. Since it's an open circle, we put a parentheses at +4. Next we have our range. We start at our lowest y value, which is -3. And then we go to our highest y value, which is 4. We don't have any open circles there, so we put brackets on both. Now we look at the intervals of increasing and intervals of decreasing. So I'm just going to start all the way from the left and take it one interval at a time. So we're increasing when x is -4 to when x is -3. And remember, when you're writing your intervals for increasing and decreasing, it's always parentheses. Next, at -3, we change to decreasing from -3 to -2. Next, we go from -2 to 0, we're increasing. Then we change back to decreasing from 0 to +3. And then lastly, we end increasing from 3 to 4. So again, domain, you're looking at the x values. Range, you're looking at y. And increasing and decreasing, you're always looking at the x values. All right, for D, our domain, we start all the way to the left and then move to the right. So left, our graph, we have these arrows, so it's going forever in that direction. So our domain is going to start with negative infinity and then end. It ends in the right direction, so it keeps going forever, so it ends up infinity. We put parentheses there, and this also can be written as all real numbers. Next we have our range. We start at the very bottom, which our graph is going forever down, so this starts at negative infinity, and then our graph ends, our highest y value is 10, so our graph ends at 10. We don't have any open circles there, so we put a bracket at that 10. Next we have increasing and decreasing. So we start off increasing from negative infinity to when x is negative 8. Then we change to decreasing from negative 8 to 0. Then we go back to increasing from 0 to when x is positive 8. And then we end decreasing from positive 8 to positive infinity. All right, let's look at number 5. So here we have a piecewise function. We need to graph the function. So first thing we're going to do is look at our first function, and we take our number here and plug it in for x. So we have f of negative 2 is equal to 4 times negative 2 minus 4. 4 times negative 2 is negative 8. Negative 8 minus 4 is negative 12. So we're going to go to our graph and plot that point. So when x is negative 2, y is negative 12. So we go to the left 2 and down 12. And we have a closed circle because this is less than or equal to. This tells us that it's going to be a closed circle. If it was just greater than or just less than, then it's an open circle. Now we need to plug in another point that is less than, or that's greater than negative 2, because here we have a greater than sign, so we plug in another point that is greater than negative 2. So greater than negative 2 would be 0. When we plug in 0, we get negative 4. So our next point on our graph is going to be 0, negative 4. So we stay on 0 and go down 4. We know that this line is going to be linear, so we can just connect these two dots with a line. Next we have a constant. We just have 2. So here, when x is negative 2, y is 2. So we're going to go to our graph. We go to the left 2 and up 2. And we put an open circle because it's just a less than sign. Now, since it's a constant, we know it's going to be a flat line, but if we wanted to, we can just plug in a number that's less than negative 2, so we could say negative 4, and y is going to be 2. No matter what number we plug in, y is always going to be 2. So we can go to our graph, we would go to the left 4, up 2, and then we just connect those two dots, and our line goes like this. Any questions here?
Miss Garber?
Yep.
How come you can use -2 for the second function if it's not like less than or equal to -2?
You use it just to see where your graph is going to start, but it's not included, so that's why we put the open circle there. So we use it to plug it in, but we use that open circle to show that it's not included.
Okay.
So we're always going to plug in these numbers that it tells us. Whether it is not included, we're always going to plug it in. All right, ready for number 6? Number 6, we're doing the same thing. Here we see that y is 0 from when x is -5 to -2. So on our graph, we're going to have a flat line at 0 from -5 to -2. So we're going to go to the left 5. We put a closed circle there since this is less than or equal to. But we're going to end it with an open circle since it's just less than. So then at -2, we have an open circle and we have a constant there, so it's just a flat line. Next, we're going to plug in -2 and 1 into our second function. So we have f of -2 is going to be -2 squared plus 4. -2 squared is 4. That negative outside makes it a -4, so we have -4 plus 4, which is 0. So our point here is going to be -2, 0. And then we have a less than or equal to sign, which means that it's going to be a closed circle there.
Ms. Carver, you use -2 because that's included in the line, right?
Right,
Or did you just pick it?
we always use these numbers just to show us how our graph's going to go, in what direction our graph is going to go. But like for this one, where it only gave us x's, for this one here, when it only gave us x's greater than or equal to -2, that's when we pull out another number that we make up. After we plug in -2, we plug in another number that's greater than -2 to show which way our graph is going. But here it gives us two numbers to plug in, so we're going to plug in those two numbers first. So we go to our graph, we're going to go to the left 2 and stay at 0. And then we also need to plug in 1. So f of 1 is going to be -1 squared plus 4. -1 plus 4 is 3. So our next point is going to be 1, 3. So we go to the right 1 and up 3. Now we see here, looking at our function, that we have an x squared. So we know this is going to be a quadratic function. It looks like a parabola, so we can't just connect these two dots with a straight line. We need to see what else is going on here in our function. So something else is happening in here. It's either going to look like this or it's going to look like this in between these two dots. So let's plug in some other numbers to see what is going on in between these two. So we can plug in 0. So we're going to plug in anything in between these two numbers for x. So anything in between -2 and +1. So plugging in 0, we have 0 plus 4. So that means our next point is going to be 0, 4. So going to our graph, stay at 0 and go up 4. And then here we can kind of tell that we see our shape of our parabola, so we can just connect these 3 dots here. Next we have this third part of our piecewise, our third function. So we're going to plug in 2 and 5. 2 is going, whatever we get for 2 is going to be an open circle, and whatever we plug in for 5 is going to get a closed circle. So we have f of 2 is going to be -2 plus 3. So our point is going to be 2, 1. So we go to our graph, we go to the right 2 and up 1, and we said that was a open circle. And then next we plug in 5. So we have -5 plus 3, which is -2. So our point's going to be 5, comma, -2. So going to our graph, we go to the right 5. And we go down 2. We have a closed circle there. And then we just connect these 2 points with a line.
How could you tell which one was open and which one was closed?
So we look at our less than, greater than, less than and equal to, or greater than and equal to sign. So always, if it is less than or greater than, it's going to be an open circle. If it's less than and equal to or greater than or equal to, it's going to be a closed circle. So just know that this line on the bottom, that equal to, means that it's including, so that's why we put a closed circle. So that line just means you fill in the circle. Any other questions from this one?
Wait, Miss Carver,
Yes.
why, did you not do what you did with the last one, find a number in between 2 and 5?
Good question. Because this one, since it's an x squared graph, we know it's going to be some type of parabola shape, so it's not just a straight line. This third one is just x, so we know that it's linear, so it's a straight line, so we can just connect our 2 dots. When it's x squared, you'll have to plug in a number in between to kind of see where that hump is going to be.
Oh, I got it. Thank you.
You're welcome. But if it's just linear, all you have to do is connect the 2 dots, because there's not going to be anything weird going on in between. Okay, any other questions on that one? All right. Number 7, we're finding the zeros. So here we set our f of x to 0. So this is going to be 0 is equal to x cubed minus 8x squared minus 9x. Now before we factor this, the best thing to do is just to pull out an x. So we take out an x from everything inside, and we're just left with x squared minus 8x minus 9. And now we can factor everything inside. So we need 2 factors of -9 that add to give us -8. So this would be -9 and 1. And then we just put those into our parentheses down here. We have x minus 9 and x plus 1. And now we set each part here equal to 0. So we have x is equal to 0, x minus 9 is equal to 0, and x plus 1 is equal to 0. X is equal to 0. That's one of our zeros. So we don't have to do anything there. For the next one, we just add 9 to both sides. So x is equal to 9 is our next zero. And then the last one, we just subtract 1 on both sides. So x is equal to negative 1 is our last zero. Any questions from that one? All right, let's look at B. So here we have to factor where our number out front is not 1. So what we're going to do is multiply the first and the last term together. So we have negative 60, and we need two factors of negative 60 that add and give us negative 7. So any guesses on that, what that may be?
Negative 10 and positive 3.
Awesome. No, negative 10 and positive 3, when you multiply those two, that would be 30. So
Negative 12 times 5.
awesome, negative 12 times 5. So we have negative 12 and positive 5. So we're going to put those into our parentheses. So we have x minus 12 and x plus 5. But we can't forget about this number out front. So we're going to divide both of our numbers in our parentheses by 2. So we're dividing those numbers by our number out front. Now if it simplifies, we simplify it. If it does not, we move it to the front of x. So we have x minus 6. X plus 5 over 2 does not simplify, so we move this 2 out in front of x. So 2x plus 5. Now we just set both of these parts equal to 0, so we have x minus 6 is equal to 0, and 2x plus 5 is equal to 0. So we get x is equal to 6, and x is equal to negative 5 halves. Any questions here?
Would you get the same thing if you divided by 2 at the beginning?
Yeah, you would get the same thing. Because this is 0 is equal to 2x squared minus 7x is minus 30. If we divided everything by 2, we have to divide this 0 by 2, this by 2, this by 2, and this by 2, and you'd get the same answer. Okay, let's take a look at C. So here we have a fraction. All that we need for our fraction is our numerator to be equal to 0. So x is equal to 0 is our answer here.
So we always ignore the denominator?
Always.
What happens if there's 0 at the numerator?
When there's a, well, if there was a 0 in the numerator, like the whole thing would be 0. Right? So if you had like...
Regardless of the fact that there's an x on the denominator?
Right. So When there's a fraction, you don't need to look at the denominator because all we're doing is setting this fraction equal to 0. And it doesn't matter what our denominator is. Anytime there's a 0 on top, if it was 0 over 100, this is equal to 0. If it was 0 over 1, this is equal to 0. So it doesn't matter what our denominator is, we just set the numerator equal to 0. Okay, we have time for one more question. I think it would be most important. Okay, on this page, going back to the ones that I skipped, so I skipped number 7D. So here, to find the zeros, we change our f of x to be 0. So 0 is equal to the square root of 3x plus 2. To get rid of the square root, we're going to square both sides of our equation. 0 squared is just 0. And it cancels out on the right side, so we have 3x plus 2. Subtract 2 on both sides, so we have negative 2 is equal to 3x. To get that 3 to the other side, we're going to divide both sides by 3. So we have negative 2/3 is equal to x. So our 0 here is negative 2/3. Okay, for number 8, we need to determine if the function is even, odd, or neither. We know if a function's even, it's going to be symmetrical over the y-axis. If it's odd, it's going to be symmetrical over the origin. So for the origin, we would flip it upside down. So we flip the graph upside down and see if we get the same thing. And then if it's neither, it's just going to be not symmetrical over the y-axis or the origin. So for A, we see that this graph is symmetrical over the y-axis, so that would make this even. For B, if we took this graph and flipped it upside down, we would get the same thing, so it's symmetrical over the origin, which makes it odd. For C, it's not symmetrical at all, so this would be neither. For D, if we take this and flip it upside down, oh, actually no, this one is symmetrical over the y-axis. So this would be even. And then for E, if we take this and flip it upside down, it's the same, so this would be odd. And by take it and flip it upside down, I literally mean take the graph, flip it upside down, and see if you get the same exact thing. To look at the average rate of change. All the other ones that I just skipped, they'll be on a video, and I'll post it after class, but I definitely want to look at this one. So for average rate of change, we need to know our formula, which is f of b minus f of a over b minus a. So here, when it doesn't give us a graph to find our average rate of change, we need to use our formula, and we just plug in our x values into our formula to get our y values. So we know that our b is going to be negative, or we could say our a is -1 and our b is 4. So we have, and again, it doesn't matter which one you pick for a or b, you'll get the same thing. So on the bottom, we're going to have 4 minus -1. And then the top, we need to find out what f of 4 is and what f of -1 is. So all we do is plug in 4 and then plug in -1 into our equation. So we have 4 squared minus 3 times 4 plus 2. And then we solve. So we have 16 minus 12 plus 2. 16 minus 12 is 4. 4 plus 2 would be 6. So f of 4 is 6. Now we need to find f of negative 1. So we have negative 1 squared minus 3 times negative 1 plus 2. Negative 1 squared is 1. Negative 3 times negative 1 is positive 3 plus 2. So this would be 6.
Isn't that 7?
1 plus 3 is 4 plus 2 is 6.
Oh wait, I put the wrong one. Thank you. That's what I did. I added it back.
So then we just solve. 6 minus 6 is 0. 4 plus 1 is 5. Since we have a 0 on top, our average rate of change is 0. So our answer here is just 0.
Like the ordered pairs into the formula.
Right, if it gives you a graph, so we would have to find f of 0 and f of 3 for A. F of 0 is, so when x is 0, we look for our y. Y would be negative 4, so f of 0 is negative 4. And then when x is 3, our y is negative 1, so f of 3 would be negative 1, and then we just plug everything into our rate of change formula.
Okay, thank you.
You're welcome. Okay, and for the last page, we started 10a, but let's finish it. So we said that f of 0 is equal to negative 4. We know that because when x is 0, y is negative 4. And then f of 3, we go to our graph, see where x is 3, y is negative 1, so f of 3 is negative 1. And now we just plug everything into our equation. So we just have to keep which one's a and which one's b consistent, so we can say that this is our a and this one's our b. So we have f of b, which is negative 1, minus f of a, which is minus negative 4, over b minus a, so 3 minus 0. Negative 1 minus negative 4 would be plus 4, so this would be positive 3, and then 3 minus 0 is 3. So here our average rate of change is just 1.